Morning to all. Today we are going to see BCNF. A relation is said to be in BCNF if and only if for every non-trivial functional dependency alpha determine beta, alpha must be a super key. Now we will see one example. Consider the relation R of ABC and the set of functional dependencies are AB determine C and C determine B. First we have to find the candidate key of the relation. For that, first we have to find the essential attribute. C and B both are part of the right hand side. So the remaining attribute is A. And we have to find the closure of A. When we are finding the closure of A, we will get only A. So we have to add some other attribute with A and try to find the closure. So we are adding B along with A and try to find the closure. When we are finding the closure of AB, we will get ABC. So AB is one of the candidate key. Okay, consider the functional dependency C determine B. So B is derived from C. So in the candidate key AB, you will substitute C for B because B is derived from C. So AC is another candidate key. When we are taking the closure of AC, we will get all the attributes of the relation ABC. So for the relation, there are two candidate key. One is AB and another one is AC. So the prime attributes are A, B and C, and the relation doesn't have any non-prime attribute. So the relation is said to be in 2NF because there is no partial dependency. The first FD is AB determines C. So C depends on the entire key. And in the second FD, C determine B. According to the definition of 3NF, if there is a functional dependency alpha determine beta, either alpha is a candidate key or beta is a prime attribute. Here C determine B, B is a prime attribute. So this FD satisfies the third normal form. So the relation is in third normal form, and now we have to check whether the relation is in BCNF or not. For the definition of BCNF, when we consider the functional dependency alpha determine beta, either alpha is a super key, alpha must be a super key. But in the functional dependency AB determine C, AB is a super key. So the first FD is in BCNF, whereas the second FD C determine B, C is not a super key. So the second FD fails satisfying the BCNF condition. So the relation is not in BCNF, it is in 3NF.